Hello, guys. So I welcome you all to this discussion, the case study of microprocessor versus microcontroller in robotic application. So let us dive deeper into it. For that, I wish you could introduce yourself and give your relevant points. The next speaker. Shall we start? Yes. Yes. And
I'm Zuma from Second I'm serious, basically MCD.
In the era of smart robotics, the choice of hardware significantly affects performance, cost, and profitability. This case study explores the suitability of microcontrollers and microprocessors in building autonomous mobile robots. It compares two popular platforms, 80 Meha 328 based Arduino Uno microcontroller and Raspberry Pi 4 Model B microprocessor through a practical implementation of an optical avoiding objectives. The evolving the functional differences between microcontroller and microprocessor architectures to implement an autonomous loop using each platform to analyze performance based on real-time control, sensor integration, processing, and power consumption. So the next topic is methodology and hardware system.
See, it can also be no.
And the component is controller. In Arduino robot, we use Arduino Uno 80 Meha 3220. In Raspberry Pi robot, Raspberry Pi 4 Quad 4 Cortex 87. In sensors, ultrasonic sensors HCSR04 and in Raspberry Pi robot, ultrasonic sensor HCSR04. In motor driver, in Arduino L298N dual HH and in Raspberry Pi L298N dual HH. For the power series, in Arduino 97 battery pack and in Raspberry Pi 5 power bank. And in chassis, two-wheel drive robot frame and in Raspberry Pi two-wheel drive robot frame. And the software and programming is Audio IDE C++ called microcontroller and Python with GPIO libraries on Raspberry Pi.
Yes, now coming to comparison of parameters, as we are using two types of motherboards such as control boards such as Arduino Uno and Raspberry Pi board. In particularly, there are some technical differences in their specifications. Coming to processing speed, Arduino Uno is about 16 megahertz of speed, and coming to Raspberry Pi 4 is around 1.5 gigahertz. That is quad core. And real-time performance, it is highly dedicated to real-time control, whereas that is Arduino Uno is highly dedicated to real-time control. Coming to Raspberry Pi is moderate because it requires OS scheduling. That is, we have to boot through OS so that we can do with next proceeding works. Coming to multitasking, Arduino Uno lacks in multitasking, and whereas Raspberry Pi 4 is excellent in multitasking. As Srinidhi has already told about programming languages. In coming to Arduino Uno, we are using C++ programming language, whereas coming to Raspberry Pi, we can use both with Python and Java. Power consumption, Arduino Uno uses a normal HW battery of 9 volts or other 12-volt DC supply as a support, whereas coming to Raspberry Pi, we have to connect a 60 milliamps charger. Sensor handling directly where you Arduino Uno has limited supports that only GPIO pin support, whereas coming to Raspberry Pi, it is also coming with GPIO plus I2C system and SPI support. And cost, Arduino is more cheaper than Raspberry Pi, but with limited features as around $10 in around Indian money is about 300 to 400 rupee, whereas coming to Raspberry Pi is cost around $130, around 2000.
Result and analysis. Arduino Uno performs better in real-time sensor activator response due to its dedicated control without voice latency. Raspberry Pi excelled in advanced tasks like logging data, camera processing, or network-based commands, but suffered occasionally delay in
motor control due to multitask. For low cost, simple robot focused on real-time control, microcontroller are preferred. For AI-enabled vision-based or network robot, microprocessors are more suitable. Conclusions. This case study highlights the practical trade-offs between microcontroller and microprocessor in robotic application. Mechatronics engineering must choose the platform based on complexity, performance requirements, and budget of the system. A hybrid approach combining both sample Raspberry Pi and serial communication may offer the best both worlds. Okay, coming to future scope, as Srija told about all these merits and about the things. And whereas future scope, we can take about Raspberry Pi because Arduino, lacks in many other tasks. Where coming to Raspberry Pi, we can integrate with the vision system that is OpenCV, and Raspberry Pi is for object detection. So, where coming to an autonomous robot, object detection feature is one of the main features. So, we can go with that. And you can use also wireless communication, that is Bluetooth BLE technology, that is Bluetooth low energy technology with Wi-Fi to extended control range, and apply 8JA with Tensor Flow Lite on Raspberry. That is, we can also coming with a AI model on a software, or we can also install it on a Raspberry model itself. So which will enhance the overall robots efficiency.
Thank you guys. Thank you for the